Yes.
Good morning and welcome to Investigation 8.1. Here we have the ocean. Well, actually we have the land and the ocean and then a measure stick.
So there really is water in here. Water.
Yep, it's legitimate water and it goes up to, each one of those marks is a centimeter, so we'll say half centimeter.
And we're going to be investigating or modeling a storm surge.
Ooh.
So this is what it would look like at, we're going to call it baseline, like just your normal ocean, a normal landform with a cliff. So notice it's kind of a just cut off.
Yeah, just
cliff.
a drop off.
And so now we're going to say that a hurricane.
Wait, we've got to write something down,
we do.
don't we?
Oh, thank you. I forgot.
Me too.
So the amount of water. We need to put that on our table. Hopefully you've already copied and pasted this into your science journal.
I'm sure they did.
Non-hurricane conditions, water height is going to be
0.5.
centimeters.
Which we like to call 5/10, half a centimeter. That's how you write it.
5/10.
And that would be the case for all the way across, probably.
Okay, so then we look at shoreline flooding. So we're looking at the shoreline up here. And do we notice any water that spilled over?
Looks pretty dry to me, Mrs.
Looks
Dennis.
pretty dry. So we can say that there is 0 centimeters of flooding.
Whoops. Oh,
0.
I love it. Okay. But now, because a hurricane's coming,
Ooh. So hurricane out here in the
water level would rise.
So the water's going to go up. We're going to make it go up to 1 centimeter.
Guess we don't need an eyedropper for this measurement. Well, the ocean came up a lot.
Okay.
Oh, we should probably put that. Oh, it's all grayed out. I don't think we have to.
Nope.
Okay, then what? What happens when a hurricane approaches?
Whew. Okay, so when hurricanes are coming, remember, we mentioned this in the introduction video,
I'm sure everyone watched it.
that in the eye of the hurricane, you have a low air pressure, right? So that will bring winds. So we're going to add wind, because that's what would happen. And as you add wind, it raises the height of the water.
Probably.
Probably.
And so you're going to watch very carefully how high the water goes up here. And then we've marked here also 2 centimeters, 4 centimeters, 6 centimeters, 8, and 10. So we can try to measure how far back the water might have gone.
Yeah, so we're looking for water height, which she just mentioned right here. And then shoreline flooding, which we'll use these measurements to track.
All right, let her rip.
Let's try.
Oh my gosh. Oh, I think it got up to that 2 centimeter one.
Ooh, 2 centimeters.
Wait, was that trial 1?
That was trial 1.
Okay, let's measure. I know it got up to 2 centimeters, so I'm going to put that on our thing.
2 centimeters.
2. Now, how far back?
See very minimal flooding.
I just see a lot of bubbles.
Yeah, so you're going to get, some splashes of water, but as far as complete flooding,
Maybe right here, this far back, because there's so many.
yeah, maybe.
Okay, well, how far is that, guys? How far? I think 4.
Looks to me to be about 4 centimeters.
Okay. I'll record it on our paper.
Okay, so now for each trial, we're going to have to sort of just pay attention.
Do we have to blow that back into the water? How do we get that out of there?
Oh, great question. Maybe we could just tap it with a paper towel.
Oh, genius. Genius. Okay, for this trial, guys, I'm going to zoom you in on the measure stick so you can try to see.
And we'll just try to get most of the water
That's good enough.
so that we get some fairly accurate data.
All right, let me zoom in. And storm.
All right, trial 2, are we ready? Ooh,
Yes.
Don't touch the water.
Oh, I think it's coming up above 2, guys. What do you think? I think it came up to 2.5.
I can tell you right now, the stick is wet up to there.
truth. It could be from wicking.
It could.
I'm gonna go, how about then we go 3, because that mark is at 3. Okay, now how far back?
Oh,
I don't think any further than 4.
I don't think so either. Nope,
Okay.
I'm going to say 4.
4 it is. Okay,
Okay, cleaning off.
sunny
one
day.
more trial.
Sunny day, a lot of,
Oh,
oh, for Pete's sake.
add more water on accident. Okay.
Okay, now I'm just gonna stay over here where we can watch the shoreline.
Trial 3. This will be our last trial.
Okay.
Here we go.
I think 2.5.
Ooh, 2.5.
But how far back?
That's
Some
some
of it got on
weird-
our paper.
I feel like I blew at a different angle that time. Winds came
did.
from a different direction.
did. Oh, wind's coming out of the southwest.
But I would say the majority of the, if we called it technically, flooding,
Yeah.
is no further than right here.
That's 4 again.
So 4 again.
Okay. Ooh, I feel like we get to do some math.
Yay!
While you're drawing, I'll do some math. I'm not
Okay,
afraid.
so if you haven't filled out your form, you should have this much done.
Sure. Now, to find the average, remember you add them all up and divide by how many there are. So 4 plus 4 plus 4 is 12, divided by 3 is 4. Huh. And then 2 plus 3 is 5, plus 2.5 is 7.5, and 7.5 divided by 3 is 2.5. How did you know that so fast? Well, those are 6th grade teacher tricks I can't share. Okay, so make sure you have that done, and we'll be back in a minute. Mrs. Dennis, what happened to our cliffs?
Oh gosh. Okay, so we've changed the shoreline to now, instead of having cliffs, we have
Slope.
a gentle slope.
And now you can see the water comes up the shore a little bit.
Yeah, so now when we record the water height, we went back to our original
Which was?
5/10 of a centimeter.
Yes, 5/10 of a centimeter.
Is how much water we have. Ooh, trying to write with a fat marker.
Yep, bad
Okay,
deal.
and now let's look at the shoreline flooding. So approximately how much of the shoreline is underwater?
Well,
And
I'm gonna say 1. Oh, over there on your side, it's kind of closer to 2, but my side, there's some zeros.
okay, so let's
do you
kind of
think?
average that out. So we'll say about 1 centimeter
Okay?
of flooding.
Gosh, it seems terrible to be starting with flooding, and that's not even with hurricane condition. What's happening next?
Shoreline flooding. Okay, so now hurricane conditions. Remember, the water rises, so we have more water.
Awesome.
We add another 5/10 of a centimeter, so now we have 1 centimeter of water.
Boy, how funny. Oh, let's record.
No,
Oh, no,
not
we
to
don't
record
record
yet.
this one. Sorry, my bad.
Okay, so now we're going to add, remember, low pressure system with our hurricane.
Yeah.
It's going to cause some winds. Whew.
I'm just so fascinated at the surface tension here.
Again, we're going to look for height of the water
Okay, I'm gonna look for height. I'm gonna
and
pay
then
attention.
depth of
Oh, gee
flooding.
whiz, this is a lot of stress.
Okay, here we go.
Definitely 2. Whoa.
Definitely
Okay, you look for how
2.
far back. I'm gonna write down 2 for height.
And our flooding,
Really is concentrated right there.
yes. So we're going to say, 6.
Oh, golly, 6.
6 centimeters of flooding. And then I'm going to wipe off this flooding part.
Sunny day. Hurricane number 2 on the way.
Okay. Are we ready? Go. Here we go. Hurricane number 2. Oh, sorry.
It's okay, I needed to get in closer. Okay. I don't think it made it up to 2 that time.
Ooh, not as strong of winds, maybe.
weaker hurricane. Okay, how far back?
Oh,
Look
boy.
how they're really concentrated.
They are. Flooding is really
Interesting.
consistent.
Oh, that might be closer to 7.
It might be.
How funny that it went in further, but not up as high.
Ooh,
7. Oh,
7.
that's going to be a lot more complicated math. Ooh, good thing.
Ooh, get your brains ready. Your math brains working.
Good thing math is a doable skill. Okay, I'm coming
Okay,
back in.
Here we go. Hurricane number 3.
Hit it. Maybe 2.
Ooh, maybe
been a
2.
Okay, what about? Oh boy,
Flooding.
you got flooding everywhere.
Woo, flooding. A little more inconsistent. I would say we have outliers. We
We
won't really
do.
count those.
But I think right there where your straw is,
I
where's
think
that?
8.
Oh yeah, that's that's close to
I
8.
think that's pretty close to 8.
Whoa. Thank
Okay.
you, because that makes my math easier. All right, let's do some averages. 6 plus 7 plus 8 divided by 3 should be 7. This one though, 4, 5.5 divided by 3. It's going to be 1 point something. Oh gosh, guys. Let's just do the math. 1, 2 left over, 8. Let's just go with 1.8.
Writing with a fat marker.
Yeah, fat marker, little tiny boxes. Okay, so gosh, what could we say here?
So if you look at,
We're looking for trends.
yeah, so look for patterns or things that you notice, like with cliffs, right? If we look at just the average, look at your average water height, and then it caused,
The water height was much higher. 2.5
Yes.
versus 1.8.
but didn't really cause as much flooding.
Yeah, inside the shore, we were only 4 instead of 7. 7 is almost twice as far.
Right, with only, 1.8 or 1 8/10 centimeters of water height.
Gosh, wonder what all that means.
Oh, so we'll be using some of this information in a future lesson. So some things you want to think about, right, are the height of the land
Yep, the slope.
and the slope.
The slope as it
Yes.
approaches the ocean. All right, anything else for this one?
I don't think so.
Okay, follow your directions in the classwork tab.